and welcome to Breck Nation. I'm Dave Jones, founder and CEO of Storm Center Communications. Welcome to all of you here in the room from the Breckenridge community, and welcome to you watching online from around the country. And this afternoon we had international viewers as well. I also want to bid a welcome to those folks at Old Dominion University in Hampton Roads that are watching live, and hopefully will be participating in tonight's discussion. We want to keep this as a fairly informal discussion where we have a lot of lights and a set behind us and all that sort of stuff. We have been participating with the Weather and Climate Summit, having TV meteorologists here from around the country to learn more about extreme weather and a changing climate and climate science. So we have two spectacular speakers this evening who are going to talk about climate change, changes going on in the Arctic, and what impacts they may have. James Balog, who is a National Geographic award-winning photographer and explorer, and also the founder of Extreme Ice Survey. I think you'll enjoy his presentation. It's very visual. And also Dr. Jim White from the University of Colorado, who will add additional science behind climate change and hopefully enter into a nice discussion here in the room and also into a discussion with you watching at Hampton Roads location at Old Dominion University and elsewhere around the country. So with that, I'd like to introduce the first speaker. We have about an hour tonight to enjoy these topics and to engage in this discussion. James Balog, he has won numerous awards for his work placing time-lapse cameras around the world facing at glaciers and watching them move. And it's just spectacular.
I'm James Balog. I'm sure you figured that out by now. I look like that guy on the movie. Do we have a microphone issue? We square? Okay. Okay. I've been a mountaineer since 1970. I've been an environmental photographer since the late 1970s, and I was trained in the earth sciences back in the mid-1970s. So I've been around this stuff for a long time. And this project that I've done, the Extreme Ice Survey, integrates a lot of these different aspects of my life, the mountaineering, the photography, and the science. Through this integration of looking at these landscapes through these different prisms, I think we're able to understand climate change in ways that have otherwise not always been so accessible. So, we okay? All right, okay. So just let me take a quick poll. Has anybody seen Chasing Ice yet on TV or in the movies? Yeah, okay, great, that's wonderful. Just to say this before we get going so I don't forget. Chasing Ice came out in 2012, and it's been on the National Geographic Channel. They have the global TV rights, and it's been circulating around fairly steadily. It's available on Netflix, iTunes, and in DVD form. So it's still available quite a bit. It was in the movie theaters through 2012, 13, and 14. It's pretty much gone from the American theaters at this point, but it does show up once in a while. So we live in a snowy place here. We enjoy a snowy place. Glaciers form because more snow falls in the winter than melts in the summer. And the snow piles up, gets thicker and thicker, heavier and heavier, and it squeezes out all the air that's trapped in the air and in the snow, and eventually turns to ice. And ice is not a static substance. It's malleable, like taffy, and it will flow downhill under the influence of gravity. So I'd like to, just to set the stage here, look at one classic glacier. This is the Khumbu Glacier in Nepal. Does anybody recognize that big mountain in the sun up there on the top left? Come on, mountain people, give it to me. Let's hear it, shout it out. Mount Everest, yes. This is Everest up here. And Khumbu Glacier flowing downhill right here. Now, you'll hear more in a second about what time-lapse cameras are, but trust me, our cameras are sitting there for multiple years watching this glacier moving. And we're going to look into this section right here, which is called the Khumbu Icefall, and watch what a glacier is. That gives you a sense that it's a living, being, moving creature. It's a river of ice, not a big static lump. That's the camera, the black box on the top right, looking in across the valley and having a look at the life of the Khumbu Glacier. This shot is over 2 years, and we're watching the ice move downhill, and it's breaking up, it's shattering as it goes, and it's flowing. That's what glaciers do. They're living. There's no such thing as glacial pace. They don't just sit there. Now we turn time backwards, push the glacier back uphill to where it was 2 years before, and then turn it on again, and away we go. The main climbing route up Everest goes right up through the middle of that mess, and that's why people get killed up there. So, I said this already, glaciers are alive. And the sense in which they're alive is that they respond to the air and the temperatures and the water supply around them. They're reacting to the world. And so they're a combination of a thermometer in the sense that they feel temperature and a barometer in the sense that they feel the movement of precipitation around them. What we see as we go around the world is that the vast majority of glaciers are retreating. It's outside East Antarctica anyway. And there are a few places where glaciers are advancing, but the vast majority of them are retreating. And the reason that they're retreating is that the climates are warming in many, many places. North America, South America, Africa, New Zealand, the Himalaya by Mount Everest, the Alps in Europe, everything is warming up. And so when we look at ice retreating, we're getting a living sampling of how the Earth is responding to the air and the changes in the air around it. As I already said, this work comes out of my early life as a mountaineer. I still climb somewhat. My knees are kind of ruined. If any of you have seen Chasing Ice, you know how bad my knees are. But I still do climb and do some skiing and some ice climbing. But a lot of this comes from all these early interests. In 2005, I started working intensely on glaciers. It led to a National Geographic story that was published here in this cover story in 2007. And there's subsequently been 2 other stories that have been published about our ice work since in the Geographic. But let me just give you a point of entry into what I was seeing as I was working through some of these assignments. That cover shot is taken on the surface of the Greenland ice sheet. And Greenland, in your stereotypical impression of it, Greenland is a big frozen icy place. It isn't. Part of it is, but a lot of it is melting. And there's thousands and thousands of rivers carrying this meltwater off the surface of the ice sheet and out to sea. It cuts these deep canyons. We don't live that far away from Moab, Utah here. And we can cut a canyon in ice in a matter of a decade that would take a couple tens of millions of years to cut in sandstone out in Moab. But because that feature looks like Moab, or the sandstone outside Moab, I called that Moab. We were the first guys to explore that canyon, so we had the privilege of naming things. Lakes of meltwater form all over the surface of the Greenland ice sheet as the May-June melt comes on, and they will fill up for a matter of a week or 2 or 3, and then all of a sudden a crevasse will open and the lake drains out. That's our campsite, the yellow tents, bottom left in the frame. Where does the water go? It goes pouring down these tremendous shafts that the water erodes into the ice sheet, and they go down 2,000 or 3,000 feet all the way to the bedrock, and then the water turns and runs out along the bedrock underneath the ice out to the ocean. And drop by drop, this is raising global sea level. As the ice sheet is melting, it's releasing bubbles of ancient air that were trapped in snowstorms a very long time ago. These bubbles of fossil air in this picture are about 15,000 years old. And you're looking at a pool that's about the size of a basketball in diameter. And it's coming up out of this melting surface. And there's literally billions of these holes. It's called cryoconite. It's a whole other story we don't need to talk about. But there's billions of these holes all over the ice sheet, this Swiss cheese that's causing this ancient air to come back to us. Of course, the glaciers flow out to sea, they break off, they turn into icebergs. The icebergs get smashed up in the ocean waves. They turn into smaller and smaller chunks. This one is about this high, about 6 feet high, and about 8 or 9 feet wide. And it's sitting there in the waves, getting broken up into smaller and smaller pieces. And this is the final relic of a piece of glacier ice, of a piece of glacier that was originally about 1,000 years old. It was formed 1,000 years ago, and now it's disappearing, and its mortal body is becoming part of sea level. Thanks for turning on that thing. I was having a hard time shouting. And finally, these chunks of ice, which I've come to call ice diamonds, get into relatively small pieces. And here I am with my daughter, Emily, walking on a beach in Iceland, holding one of these chunks. And only the children in here know if she's looking at me with that look because she's mad at me for making her hold this frozen chunk of ice. But she swears she wasn't. Anyway, when I saw all this happening to the glaciers, and I had experienced it as a mountaineer, and I experienced it as a scientist and a photographer, I thought, you know, looking at it in a single snapshot wasn't enough. We needed to make a record of how things were changing over time. And at first, I thought I would simply go back. That's what I do as a photographer. I've been shooting for Life magazine and the Geographic and Smithsonian for 35 years, and we just get accustomed to traveling. So I thought, okay, well, I'll just have to go back every year. And then one day I thought, well, why do that? Why not leave the cameras behind? And that's what we wound up doing. When you leave a camera in one place, and you have a computer, a little custom-made computer, some sort of a timer that tells it when to fire, and it clicks away every day or every hour or whatever, that's called time-lapse. You're working with time, and you're capturing time in these slices on an episodic basis. So initially, we put out 25 cameras, and they were shooting once an hour as long as it was daylight at all these different sites around the clock, watching the changing landscape, trying to capture a sense of how these apparently big static rivers of ice were changing as a consequence of the impact of the climate. The system is based on an Nikon camera that sits inside a Pelican housing that we've custom modified with a plexiglass window. Solar panels feed power into it, and there's a little custom-made computer that tells the thing when to fire. I'm not an electronics guy by a long stretch of the imagination, and this was actually the hardest 6 months of my life, was trying to figure out the electronics to make this beast work. But they worked, as you're about to see. Nuts. I forgot to correct this slide again. But right now, as we stand here tonight, we've got 48 cameras in different places around the world. They're in Antarctica, they're by Mount Everest, Austria, Iceland, Greenland, you can see where they are. We also go back to certain places on a regular basis and take a picture with a tripod in exactly the same place to see how the landscape changed since we were there last. Now, this is some techie science stuff, and we're trying to allow a lot of time for conversation tonight, so I'm going to get through this pretty quickly. This is a record of ancient climate that goes back about 400,000 years. And this record basically goes back with the same rhythm about 1 million years. This record of ancient climate temperature, the temperatures, the connection with the carbon dioxide in the atmosphere and the sea level, all of this is known from careful study of trapped molecules in the ice sheets, ocean sediments, and a lot of other things that people have spent a lot of time working on. The big story that I want to give you is this. Today, our lives today are over on the far right side of the picture. This is 400,000 years ago on the left side. So nature, if left to its own devices, oscillates through patterns of hot and cold, high carbon dioxide, low carbon dioxide, and it's connected with something called the Milankovitch cycles. It's the way the Earth moves around the sun and the way the axis of the Earth wobbles in space. And that creates hotter and colder periods. And there's a rhythm to this. Warm, cold, all the way across through time. Earth if there's no other inputs, peaks out at a carbon dioxide level of about 280 or 290 parts per million of carbon dioxide in the atmosphere. Right now, we're at 400 parts per million. That's 40% above the highest natural variation in a very, 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 very long time. And the only reason for that is the surplus carbon that we're throwing into the atmosphere from burning fossil fuels, from deforestation, from a bunch of things like cattle that put methane in the atmosphere and so forth and so on. So so that's a big important thing. There's a natural, nature has a natural variation, but it stops at 290. We're at 400, and the only reason for that change is human impact. There's no other answer for it. So we are now in basically an uncontrolled science experiment. We've warmed in the past 100 or so years about 1.5 degrees Fahrenheit, a little bit more than that, but basically 1.5 degrees Fahrenheit because of this excess carbon in the atmosphere. Jim, every other scientist, and myself can't overemphasize the fact that this isn't a matter of computers and statistics and projections and computer modeling and imagination. It's a function of the physical characteristics of the atmosphere. It's about the chemistry. This has been known since the 1880s, that if you alter the composition of the gases in the atmosphere traps heat differently, and the atmosphere warms up. So it hasn't come about, this idea of global warming and greenhouse gases, because a bunch of crazy hippie scientists from Boulder, where I live, or crazy hippie scientists from Berkeley or some other place came up with. This is just basic physics and chemistry, and you can't argue it away. That's what's so aggravating sometimes about the society's resistance to dealing with this. This is physical fact. And here is a little computer animation from NASA that shows how the Earth is warmed over the past 140 years of the instrumental record. And you can see the Earth kind of staying somewhat stable, warming up a little bit up until about 1970. And all of a sudden, the yellow comes on, the orange comes on, the Earth gets warmer and warmer and warmer. That's a function of all of these gases in the atmosphere. And there's so much of this warming that's concentrated in the northern hemisphere, in the Arctic areas especially. So here's what our time-lapse cameras see. This is at the Mendenhall Glacier in Alaska. And this is 7 years worth of watching the rhythm of the ice. So the glacier's flowing forward, but it's not flowing forward fast enough to replenish the ice that's breaking off into the water. And so the glacier retreats, net retreat. So the red line is where we started. Without the memory of that camera, you wouldn't remember that the glacier was up, filling all of that volume. And now there it goes away. And it's continuing to retreat. This is a one-way story for the foreseeable future. Let's go to Greenland. And let's look at this gigantic wall of ice called the calving face, where a huge glacier, what happened to my location map? Gee, I'm sorry. There's a picture here. But in any case, Greenland is dumping out into the ocean in this picture. And let me start this again here. That annoys me. Sorry. Greenland is a gigantic mass of ice. Okay, we'll look at Alaska again. Okay. That's a waterfall on the right, by the way, that comes and goes, and it ultimately turned into this massive flow as this melt carried on. So Greenland, as we know, is up in the northern part of the Atlantic Ocean, and it's a huge subcontinent-sized area covered with ice, about 2 miles thick, and it sends ice out into the ocean through these different conduits, these big glaciers that come down these valleys and calve off these icebergs. The walls of ice where the ice calves off are called, it's called a calving face, C-A-L-V-I-N-G, okay, calving. Why somebody decided to name them after baby cows is beyond me, but that's what they are. So in this shot, we're going to show you the single biggest outlet glacier in Greenland that dumps more ice into the ocean than anything else up there. It's called the Ilulissat Glacier. And we knew that there would be episodically big events. We didn't know when exactly. We thought it more or less in the Greenland spring, which is May and June. And so I got a couple of my team members to volunteer to camp out and watch 24 hours a day. We had 9 cameras set up on tripods, protected by heavy rocks against the wind because it blows like a hurricane up there. And their job was to have somebody awake so that if there was a big calving event, you could turn on the cameras and capture a record of it. That's what we're about to see. And so we start with the helicopter seen against the calving face to give you a sense of scale. There's billions of tons of ice that come out of this place. That's Atlantic Ocean seawater on the bottom covered with icebergs. Now the helicopter shrinks and disappears in the immensity of this landscape. You're looking about 2.5 miles across left to right. So we turn on the Greenland conveyor belt, pouring ice into the ocean. Here it goes. Summer, winter, summer, winter. It runs on average about 125 feet a day. The iceberg that sank the Titanic is believed to have come from this spot. It's a massive producer of blocks of ice. We've had to turn the camera to keep up with the retreat of the ice out of this valley. In fact, this coming summer, we're going to reposition the cameras up in a different spot entirely because the glacier is retreating so fast and so far that this camera site is no longer keeping up with it. So as we were trying to get one of these big events captured in detail in video and in stills, my guys were standing there camping the promise was that they would be there for 4 weeks. And they called me up on the satellite phone. I was back in Boulder getting ready for another Greenland expedition. They called me on the satellite phone and said, "We're going crazy. We've been looking at this thing too long. We can't stand it. Can we leave someday really soon? Because we're tired of staring at this." And literally in the middle of that phone call, Adam Lewinter, my field assistant, said, "Wait, Jim, Jeff is over there by the cameras shouting at me. Maybe something's about to happen. I'll call you back." And he calls back 20 minutes later and he said, "The whole place is blowing apart. It's just pandemonium here. I've got to keep up with the cameras. I can't talk to you. I'll call you back." So I don't hear anything for an hour. I'm thinking, what's happening? What's happening? I can't wait to hear. He finally called back and he said, "We're shaking. We're speechless. We're so wrung out by this. We've just seen this massive calving event, and it turned out to be the biggest calving event that's ever been put on film." That's one of the culminating episodes in Chasing Ice, the film that some of you have seen. So here's what that looks like. And let me set the stage on this a little bit. The ice that you're seeing above water in these pictures is 30 to 60 stories tall above water. And it's roughly 2,000 to 2,500 feet tall underwater. So these are enormous volumes of ice breaking off. I mean, twice the height of the Empire State Building, let's say. If you've ever been to New York, that's a big chunk of ice. So this is what the boys saw that one day in May 2008 with this enormous calving event. So to give you a sense of scale, we put this little cheesy illustration over the picture so you can get some grasp of what's, sorry. Boy, oh boy. I'm not on my keys here tonight very well, so my apologies. Okay, so to give you a sense of scale, it was a mile in and out. It was 3 miles left to right, this block of ice, and it was 3/5 of a mile deep. And what that translates into is that it was about 2 Golden Gate bridges wide. And then here's the arithmetic problem they love to hear about in Washington. If you tried to fill that block with the U.S. Capitol building, how many Capitol buildings would it take to fill the block? And the magic answer is 3,000 U.S. Capitols. So it's a huge chunk of ice. Really, really an amazing thing that we were able to witness. So that's my story for right now, and I'll turn the baton over to Jim, and we will go on with some other thoughts here. Let me get you queued up.
Thank you all for coming. Jim and I have known each other for a while. I'm a professor at the University of Colorado in Boulder and have studied what's called paleoclimate, or how the climate system works in the past. I go to places like Greenland and collect ice cores. The places I go are not scenic by any stretch of the imagination. So what you just saw from Jim is way more interesting than what I could possibly show you. Most of the pictures I have from the ice sheet, it's white, it's flat, the wind blows. Even the videos aren't very exciting either. So. But I thought what I could do here this evening is very briefly, and I want to make it very brief because I want to leave time for questions, is give you some thoughts on a couple of things. One is physics. So I think it's important for everyone to recognize that the reason why there's such a broad consensus in the scientific community about climate change is because the physics of climate change are very simple. And when you have simple physics, you really can't do anything other than yes. I mean, it exists. So for example, we don't argue about gravity. None of us here lives in deathly fear that gravity might just quit on you and you float aimlessly up to the ceiling. Right? It doesn't happen. The same kind of certainty exists in the fact that some molecules, because of the mass of the molecule, are going to vibrate with the frequency with which the Earth radiates energy, and therefore they will absorb the Earth's energy as it tries to escape, and in absorbing the Earth's energy, they increase the amount of energy in the atmosphere, and energy in the atmosphere is climate. Okay, so there's some things that we can say about simple physics that I think are very powerful. And then I want to finish up with just some thoughts on what I think is a part of the discussion that we don't get into enough, and that is ethics. What's right, what's wrong, how do we view climate change in a more moral sense? We seem to always talk about it in terms of the economy. And so I think it's time we actually started thinking about these things a little bit more broadly. So I'll start with simple physics. I'll do the science part of this. Interestingly, and this is lesson time here, folks. This is, professor does a little teaching. It turns out that if you want to know the temperature of our planet, or if you want to know how much energy is in the atmosphere, that's a simpler thing. You only need to know 3 things, which is pretty cool if you think about it. You need to know how much energy we get from the sun, because we're a sun-driven planet. There's a little bit of heat coming out of the ground from radioactivity and from friction as one continent smashes into another continent, but it's pretty small. And if we had to rely on that, we would all freeze to death. So we get our energy from the sun. So if you know how much energy you get from the sun, then that's one of the things you need to know. The more energy you get, the warmer the planet is, the less energy you get, the colder the planet is. The second thing you need to know is how much of that energy is reflected back to outer space. And that's important because at times our planet has been a snowball. It's been so cold that all the oceans were frozen over, all the land had ice on it, very white, very reflective. The sun's energy wasn't able to be absorbed, and the planet got very, very, very cold. Right? On the other hand, if there's no ice on the planet, which was true about 40 million years ago, there was no Greenland, there was no Antarctica, the mountain glaciers were melted. By the way, sea level was about 80 meters higher because all that land ice went into the ocean. At that time, the Earth was all very dark, it was very warm, very absorbing planet, And so reflectivity is something that we need to understand. The third thing we need to understand is something called greenhouse gases. And those are just the gases that, by the way, every molecule vibrates. And we'll slip into some chemistry here. So every molecule is going to vibrate. So pretend I'm a nitrogen. So here's nitrogen, and I'm my other nitrogen, N2. So I vibrate. And the frequency of that vibration is dictated by the fact that nitrogen has a mass of 14. And so there's a frequency that's inherent with that mass. Right? So any molecule that has the right frequency that absorbs the Earth's outgoing radiation is what we call a greenhouse gas. The number one greenhouse gas in the atmosphere is water vapor. After that, it's CO2, methane, other gases. There's not very many of them, thank goodness. Nitrogen and oxygen are not greenhouse gases. They do not absorb the Earth's outgoing radiation. If they did, we would have an extremely hot planet. All the oceans would have boiled away a long time ago. We can be thankful about that. So if you know how much greenhouse gas you're in the atmosphere, if you know the reflectivity, if you know the amount of energy we get from the sun, all of these things we knew back in the 1850s, for example, you can determine how much energy is in the atmosphere and you can calculate the temperature of the planet. Turns out when you make that calculation, you get a temperature of about negative 18 degrees Celsius. Right, that's the temperature we would get from the sun. That's when physical scientists began to think there's got to be something more to this, and that's when that greenhouse gas piece began to come in. As we began to understand greenhouse gases more and more and more, we recognized really that the difference between what we actually measure on the planet for our temperature, which is plus 15, and the temperature that the sun would like us to be, which is negative 18, the difference is made up by the fact that greenhouse gases absorb energy in the atmosphere. So greenhouse gases, without any human intervention, by the way, make the Earth about 33 degrees Celsius or about 60 degrees Fahrenheit warmer. And interestingly, if you think about it, negative 18 is pretty cold. You guys get that occasionally up here. You know how cold that is. That's not going to be a planet that has sophisticated life. Plus 15 is a very nice planet. Warm at the equator. It's cold enough that you can go skiing here in the wintertime. So this is a very, very nice planet. And the difference is greenhouse gases. Without them, we don't have a habitable planet. Okay, so if we add lots of greenhouse gases to the atmosphere, we will change the energy of the atmosphere. About 50% of the energy of the atmosphere is sensible heat. About the other 50% goes to evaporate moisture and winds in the atmosphere, all the other things that happen out there, right? But with 50% of that going to heat, or how we feel, how we sense heat, it's an extremely good bet, or a very solid conclusion, depending on how you want to say it, that if we increase greenhouse gases in the atmosphere, we will increase the temperature of the planet. I mean, one thing we will do is change climate, because climate is the amount of energy. Right? So this is why, I mean, and what I've told you in 2 slides is the simple physics of it. It's the reason why climate scientists say that if human beings put lots of greenhouse gases in the atmosphere, whether that's by fossil fuel burning, or whether it's rice cultivation, or whether it's animals that belch out methane, it doesn't matter. If those greenhouse gases go in the atmosphere, we will change climate. Right? And we are changing climate. And so when people ask me, is climate changing, I say yes, so that's pretty clear. Are human beings one of the causes of it? The answer is yes, that's also very clear. All right, so I want to give you quickly then some thoughts on ethics. I'm showing you my granddaughter. This is Amelia, Emmy. This is about a week ago. She's 1 year old. I love the bathrobe and the fact that she always carries her babies like this. Right? Carrying them upside down seems to be the way things work in my house. I'm showing you her for a couple of reasons. One is I think we have an obligation to the future, to future generations, that I think we are punting, that I think we're failing. I think we're not doing a very good job. And I'll elaborate on that. The second thing is Emmy's a woman. Emmy, well, not a woman yet. She's female. She's a girl, a little girl. And one of the real issues that we have on the planet is the relationship between men and women on the planet. And I'll loop back to that. And it may not sound like it has anything to do with climate, but it does. Okay. So how do we get from where we are, how do we deal with climate change, how do we get to what we call sustainability? Sustainability is a goal. We want to be able to sustain the lifestyle that we have on this planet. Right? So here's thought number 1. We say we love our kids, but do we show it? And I don't really think we do. We live on a water planet. That's hopefully not a big surprise to everyone. Because we live on a water planet, because it takes water a long time to warm up and to cool down, anyone who's put a pot of water on the stove to boil knows that. Here's a thought experiment. Put 2 pots on the stove, identical pots. Put water in one, no water in the other. Turn the heat on identically. Go away for 3 minutes. Come back and put your thought experiment finger into the water. It will not have changed very much. Put your thought experiment finger into the pot. What's going to happen? That hissing sound is your finger burning, right? The same amount of energy went into the 2 pots. Why is the water not warmed up? The answer is heat capacity. Water has an enormous heat capacity. It takes it a long time to warm up. It takes it a long time to cool down. So Jim told you we have 400 parts per million CO2 in the atmosphere. We don't have a climate today that is 400 parts per million. That will not come until another 50 years or so when the ocean's warmed up. Right? We've got 400 parts per million of CO2 in that burner heating away on the stove, but until the water warms up, we won't have that climate. Right? This creates something called intergenerational inequity. It means that what we do to the atmosphere today, our kids are going to have to live with. And what they do to the atmosphere, their kids are going to have to live with. And until one generation says, wait a minute, maybe I ought to think 50 years down the road and not 3 months down the road. Until that happens, we will continue to do this. We will continue to pass on to the next generation the climate problems that we have. All right, that's thought number 1. Thought number 2, if you don't control population on the planet, you're not going to solve any of these problems. Right? There's 7 billion of us, and there's more and more and more. You talk to demographers, and it's not a secret. If you want to control population on the planet, guys, learn to share power, learn to share wealth. Because when women have political power, when women have economic power, the number of children born to those women goes down. Because they have very strong and very meaningful lives outside of childbearing. They have very strong and meaningful lives within childbearing, but outside of childbearing, they also have very strong and very meaningful lives. Today, around the world, for about 3 billion people, 1.5 billion women, their status in their society is linked directly to how many kids they have and how long they work in the fields. Right? If you've got that situation, you're never going to control population. So I think until men learn to share power with women, you're not going to deal with this problem. Third issue I want to tell you about is today on this planet, some 2 billion people, they don't care about the environment. And it's not because the environment's not important to them, it's because they care about where their next meal's going to come from. They care about putting shelter over the heads of their children. They can't afford to care about the environment. So we live in a world today where we're not going to really address these problems in terms of how the planet functions, in terms of sustainability, in terms of climate change, until we have everybody on the planet jumping in and sharing in the solution. And they can't do that unless they have some level of comfort, if you will, economically speaking. So until we have enough wealth equity that the poorest of the poor can participate in the economy, you're not really going to solve this problem. All right, now, if you think about it, I told you 3 things that I think we need to do in order to move towards sustainability. All right, we need to value our children. We need to, men, share power with women. And we need to learn how to share wealth on the planet. The really cool thing about that is for us to move forward in terms of climate change and in terms of sustainability, we have to be better people. We simply have to be a better species. That's good news. All this stuff about climate change gets us all excited, all nervous. It gets me excited and nervous as well. But the cool part about it is the solution lies in us just plain being better people. And that is one of the most positive messages I could leave you with. And I think Jim and I would be happy to sit up here and take questions for as long as you wish. Come on up, Jimbo.
to do is now it's time for question and answers. We're going to pull the chairs right over here in front of the monitor, and then Jim and James can have a little bit of a rest while drinking some water as well. For those of you watching online, we're at 9,600 feet elevation, and so when you drink lots of water, but take a breath before you ask your questions. Of course, if you live here, you're already acclimated to this altitude. So we also have a number of questions that have come in online, and we're going to be asking those questions as well. Logistically, what I'd like to do, you're getting the benefit of the television meteorologists that are here at the Weather and Climate Summit. Brad Panovich, who's an on-air meteorologist in Charlotte, North Carolina, and Jennifer Rukavina, who's an on-air meteorologist, chief meteorologist in Paducah, Kentucky, will be giving you microphones, so please raise your hand if you have a question, and look to Brad and look to Jennifer for the microphones. And then we'll turn to Sarah Perfader. Pardon? I will. I have to switch computers once we do that. But once we start asking questions, Jim and James will answer, and then we'll ask questions online. Sarah Perfader is our social media producer in the back, and she has a ton of questions. So we're going to get right to it. So please raise your hand if you have questions here in the room. Okay, we'll go with the first one. You have mics on.
Still on.
I'm Roger. I live in Breckenridge. My question is, on the graph you showed all the CO levels going up. One at the end went up to 400, but the peaks were at 290. What causes the CO levels to drop suddenly over historically?
Those are the Milankovitch cycles, this movement of the Earth around the sun, the changing orbital pattern around the sun. It changes, as Jim was saying, the incoming heat from the sun is not a constant. It changes based on the shape of the orbit of the planet around the sun.
I can give you, all right, I'll try this in 30 seconds. Because what you're asking is a very interesting question, a very interesting climatological question. Why is it when we get more energy from the sun, there's more CO2 in the atmosphere? And when we get less energy from the sun, there's less CO2 in the atmosphere? The answer has to do with the ocean, the way the ocean circulates. During warm times, the ocean has vigorous circulation, particularly from deep water coming up to the top. Now let's think about death for a moment, all right? If I drop dead in this room, and you all kind of, very nervously filter out, I will decay and go up into the atmosphere as CO2. If I did it in the ocean, I would fall to the bottom of the ocean. So anything that dies in the ocean is going to accumulate carbon down deep in the ocean. So the vigor with which the ocean circulates and brings CO2 back to the atmosphere dictates how much CO2 is going to be in the atmosphere. When our planet is warm, we have vigorous vertical circulation. When our planet is cold, the whole thing slows down, carbon accumulates deeper in the ocean, CO2 levels drop. Does that make sense? Sorry I had to bring death into that, but felt compelled.
Sarah has an online question.
Okay, can you hear me okay? Okay. The first question that came in from the ODU audience was, is the Antarctic melting as fast as the Arctic, and why or why not?
Antarctica is not melting as fast today as Greenland and the Arctic overall. Different answer if it came to the ice sheets, because we don't really know the answer when it comes to the ice sheets, how much ice is coming out of Antarctica, how much ice is coming out of Greenland. But the difference there has to do with the fact that the northern hemisphere is a land hemisphere. The Arctic is actually an ocean. And the southern hemisphere is really an ocean hemisphere. And it has land at the pole. Those differences end up generating differences between the hemispheres in terms of how rapidly things warm up, how rapidly things cool off. And it turns out the more land you have, the more dynamic it is. The more it can heat up rapidly, the more it can cool off rapidly. And so the Arctic is actually warming faster today.
And then a corollary to that is something called Arctic amplification, that as you take that reflective ice out of the Arctic Ocean, the the sun becomes, it's looking down on dark water instead of reflective ice. So that black ocean just keeps sucking in more heat, just like a black t-shirt does on a summer day. So the more ice you take away, the more heat that gets absorbed in the Arctic seawater, and the warmer it gets. And then guess what? You have less Arctic sea ice, and the process keeps feeding on itself, which is why we're seeing this rapid decline of the Arctic sea ice in the summertime up there. As you get more warming, you get this feedback, and it just keeps getting warmer. What he said.
So to follow up, if warming continues, how long before the ice is gone, and what happens then?
How long? So in the Arctic, we predict somewhere in the next anywhere from 5 years to 25 years, something like in that ballpark. You'll see ice in the summertime gone. Keep in mind that the sun goes down in the wintertime and it's dark and cold, and it will continue to freeze. When Arctic sea ice is gone in the summertime, you will see, I think, some very interesting changes in weather. And that's something you folks here in Breckenridge, keep an eye on this. The Arctic is where a lot of change occurs, and you should watch Arctic sea ice, because as that changes, that may have profound impacts upon the jet stream, upon how storms come through here, and therefore the amount of snow you get, when you get rain, when you get precipitation. We don't know the answers to that question as well as we would like, but we do know that when that ice is gone, you will see some interesting changes. Yes. Your intuition is correct. If the ocean has most of the heat, then how the ocean circulates, for example, if cold ocean waters come up to the surface, our planet is cooler. The air is cooler. The atmosphere is cooler. That leads to natural cycling of climate. So the El Nino, all the other kind of cycles that one hears about on the 3 to 10, 20-year time scale, that's driven by ocean circulation. There's natural variability in the system. What we've seen over the last 100 years are two things: natural variability, but on top of that, a rising baseline because of greenhouse gases. And so if you look at the temperature of the planet, it's a wiggle that goes up and up and up. And sometimes it doesn't go up very fast, and sometimes it goes up very fast.
Slower.
Oh, I'm sorry, slower.
Questions in the room? Yes, sir. Go ahead, the microphone for you.
Oh, thank you. I was wondering if you could talk a little bit about the policies that need to be changed in order for us to make a difference in this area.
Go for it.
Well, let's see. What time does the sun come up tomorrow morning?
Neither one of us are shy on this, but I want my buddy going.
Oh, God. There's a complicated interlocking web of variables that apply to this issue. And you can't separate one from the other. They all connect. Most of us who spend a lot of time obsessing about this and stressing about it at 3 o'clock in the morning when we're laying in bed, it all seems to boil down to the fact that we need to properly reflect the cost of carbon burning in our economies. Basically, the air is considered to be a free garbage dump. We do not assimilate into the pricing of our fuels, our electric lights, the cost of our clothing, all the rest of it. It doesn't very well incorporate at all the environmental, military, and medical costs of dumping surplus waste into the atmosphere. And so what we wind up having is a market system that is essentially organized in favor of burning more carbon. We're seeing that right now. This fantasy that we're living here in the United States, oh, hallelujah, we have gas that's only $2 a gallon. The market system is telling us it's just fine to keep burning more carbon. It's not taking in these other costs. I wish you all could have been here to listen to the Admiral who was here yesterday talking about what it's going to cost the U.S. Navy, just that alone, to refurbish the ports that are connected with climate change and rising sea level. This is a very, very big and very expensive issue. But the costs of these things are distributed throughout the economy. They're not embedded in price at the pump, on your electric bill, or anywhere else. And that's a really big problem. And that's leading us to continually make mistakes in our societal reaction to how we use energy. The Europeans in general have been ahead of this, ahead of us on this for quite a while. Their fuels cost a lot more over there. And our reaction to saying, well, if it's cheap, we'll just burn a whole bunch more and not care about the future, that's a big mistake. And then in turn, the financial and business enterprises that have a vested interest in maintaining the status quo are happy to say, hey, that's our business. We sell this stuff. It's okay. Our job is to return shareholder value. So if people want to burn this stuff, we'll burn it. But people aren't looking out for the long-term quality of human life.
I would just add that I mean, to say what Jim just said in a different way, we don't have an energy policy. This country just simply does not have an energy policy. And so we don't face issues like Jim was talking about. We don't deal with those things. I mean, yes, the U.S. Navy is going to have to spend billions of dollars. Guess where that money comes from, you know?
Your pocket.
That's our money. That's our money. So this is, you know, I think we need to have that intelligent conversation about how we're going to move forward in terms of energy. And I think that the places on the planet that are most susceptible to, for example, climate change, which is a byproduct of not having an energy policy, places like Breckenridge really ought to be yelling and screaming very loudly. Yes, we need to think about this. We need to be adults about this.
Hi. I'm not used to speaking on mic. So you mentioned earlier that about 2 billion people on Earth cannot care about climate change because they care about surviving and feeding themselves. And these people probably contribute to, for the most part, to the overpopulation. They're the people who, like you said, probably produce the most kids because they have the less wealth and maybe education, and also it's a survival thing. So we have that on one side, and then we have the wealthy and wealthier countries on the other side, the US, Europe, China, some countries in South America that, with the wealth that they have, instead of caring more about what's happening to the climate, are trying to get richer and richer, and care less in a way to what is happening. So what is the most important thing to do? Is it to try and make these poor countries wealthier to contribute less to overpopulation, or is it to work on our countries first and try and convince politicians and people who do the regulations or the lack of environmental rules to do something first?
This is a really huge issue, and every time there's a United Nations Climate Summit, that's what the argument's about. I was at the big Copenhagen meeting in 2009, and that's what people were slinging mud and throwing arrows and arrows and stones for 2 weeks. It's because you have this divide between wealthy countries and less wealthy countries, and frankly, countries that are relatively impoverished. My answer to all of this stuff is that, to me, after a while, it sounds like my brothers and I, kids squabbling and fighting. I was the oldest of 3 sons, and the 3 boys would get in a little snit down in the basement recreation room one day, and my father would come stomping down the steps and say, "Why is Michael crying, and what's going on down here?" And the 3 boys would go, "He did it." Everybody's pointing in a different direction. "He did it, he did it, he did it." And I am so frustrated because a lot of the time here in the United States, we talk about China and India. What are we going to do about China and India? I don't think it's for us to say what to do about China and India. The main problem is for us to clean our own house and get our own act together and do what we can do with the resources, the people, the technology, and the intelligence that we have in this country. And we've been squandering that, and we have not stepped up to the plate.
You have an online question?
Okay, can you hear me okay? I'm going to generalize this one a little bit. we talked a lot about the man-made contributions to climate change and introducing things into the environment. So we do have a viewer that was wondering if things at a larger scale in an event that might have a singular impact, like a nuclear detonation that introduces things in a burst, maybe chemicals and other things in the atmosphere. What kinds of an effect that might that have on our climate long term?
Well, let me answer this by answering a totally different question. People ask me, I get asked a lot, you know, is climate change going to ruin the planet, kill the planet? And the answer to that is no. The planet has been warmer in the past, and I don't think that by adding greenhouse gases to the atmosphere, human beings can destroy the planet. We can make species go extinct, we can do some pretty nasty things, but we can't destroy the planet. If, on the other hand, we decide to shoot off all those nuclear weapons that the questioner seems to be putting into here, we can make a huge mess out of this planet. I think that's, you know, when I get really worried about stupidity, that's the thing I worry about. There's still hundreds of nuclear weapons pointed at this country, and I'd love for those to go away. And a single one would make a mess, but a bunch of them are going to make an even bigger mess. That's the way to destroy the planet, if that's your goal.
And I'd like to revise in the same spirit my last answer. I was sounding very critical of this country. This country has also been making gigantic strides. I go to a lot of conferences. I meet a lot of smart people who have recognized that the great fortunes of tomorrow are in the process of being made today by the energy innovators, by the policy innovators, by the financial engineers who are trying to make this world a better place. In the environmental community, there's been a lot of carping and griping about the current administration. Well, we haven't done enough about climate change policy, but guess what? What we've done is revise the automotive fuel standards. We've set a whole different target for the next 15 years than what we had. And that has been attempted for many, many decades. And it always got shut down by certain people in the House of Representatives from Detroit because the car companies didn't want to change. And the current administration has made that change. That's a highly positive turn of events. And the limitations that are on the emissions coming from the coal-fired power plants, that's vital and important. These are good things that people are paying attention to and stepping up on. Yes?
I liked your analogy about the heating the water and how long it takes and how long it takes to cool.
Yeah.
It seems that we're still heating.
We're heating, yeah. Yeah.
And what I wondered was, as you look out on the world, what areas of the world do you feel are in the most imminent danger of a heated climate?
Of a warmer climate? That's a great question. I think that, the question is, what are the areas of the world that I think are most vulnerable to as climate is changing? I think there's two areas that you need to be concerned about. Big area is sea level rise, which is sea level is going to rise. I mean, the physics there are also very simple. And a huge fraction of the Earth's population lives near the coastlines, and particularly in poor nations where people don't really have anywhere else to go, you're going to create lots of refugees. And one of the things that we've learned over the last 10 years is that you do not want large refugee camps because that's where bad ideas get turned into bad action. Right? So that's part of the other part of it is water. I think water is something, we talk about temperature all the time, we talk about global warming. We ought to also be thinking about global precipitation change. It's not nearly as sexy, but it's, you know. So West, you know, we are heavily dependent on water here in the West. And there's not a lot to go around. And, 10, 20, 30% change in precipitation, very, very possible, would be a big, big blow to the economy of Colorado and also just to the beauty of this state and to the recreation and to all the fun that we have and to the free reservoir you have, you know, that's draping the hillsides that we're skiing on. So water is a big issue, and if you look around the world, there are many areas where water is a big, big problem. Jim can talk about the Andes, the people who are dependent on water in China, in India, in places that really can't adapt very well. These are going to be very critical areas in the future. And frankly, you know, food depends on water. You can't grow crops without water. We are really pushing the envelope when it comes to the ability to grow enough calories for all of us on the planet. So part of the answer is there are specific locations, but the other part of the answer is because it's a global economy, we're all at risk in some very measurable ways.
From sea level rise, the two places in the United States that are most vulnerable are southern Florida, particularly Miami Beach, with a couple tens of billions of dollars worth of real estate, and the area around what's called the Delmarva Peninsula, Delaware, Virginia, Maryland, Norfolk, Hampton Roads, all of that's very flat-lying and subject to a lot of sea level rise, and there's also some of what's called isostatic changes connected with still ongoing deglaciation from the old ice sheets from tens of thousands of years ago. Another area where there's potential for huge sea level rise impact is in Bangladesh, essentially, with hundreds of millions of people living within a few feet of sea level. And it's a series of ongoing disasters in the past, and it will continue to get worse as the ocean rises.
In the mainstream media and in the political world that we live in today, there are oftentimes talk about disagreement about whether the science is there to prove or justify that it's caused by man. And that has to be very frustrating to you guys. What more do you think that the scientific community can do to move the public and the media and the political system to accept these profound findings and move in a more constructive direction?
Let me tackle that first and then turn it over to Jim. I don't know that the scientific community can do a whole lot more. I don't know how clear I could be than I tried to be this evening. I think really the onus shifts a little bit back to all of us. You know, we need to quit electing people to Congress who don't think that climate change is real. And it's not just climate change, it's science. You know, as scientists don't have, you know, an agenda. We try to understand how the planet functions. There's only one correct answer out there. Whatever the Earth tells us, that's the answer, right? So, and we ought to be smart enough as people to use that to our benefit. I think a nation that does not use basic scientific information as the fundamental underpinning for some fundamental decisions about how to move forward is making a huge mistake. I mean, the word boneheaded comes to mind sometimes, you know? And I think and I get frustrated by it, because I think that we really are stuck in a very childish, you know, the three Balog boys in the basement fighting mode, instead of moving forward in a much more adult, you know, okay, climate, now what? What are we going to do about this? What are the economic benefits? What are the economic losses? I think, like I said, it's got to really fall back on all of us to be diligent when it comes to voting. You know, look at how people think about climate. If somebody runs who says, I don't think climate change is real, don't vote for them. All right? I'll put it simply like that. All right? And maybe that'll change things. But I also think that, again, the bigger issue here is science and how we treat science in this country. And I think that that is just a recipe for disaster.
In a companion sense, it has always struck me that the further we go into this era of culture and society that's so dominated by entertainment and amusing yourself and this sort of narcissistic pleasuring, the worse our reactions to serious things in the world are getting. We're so focused on this idle distraction all the time, and frankly, I don't allow my daughter to sit there playing with apps. You know, I want her to focus on the dimensional world. That's more important than some silly game. And I fear that as as an intellectual being, Homo sapiens, for everything it's gaining through the power of the information age, it's losing some other things, some profound connections with the natural world, with the dimensional world, with a sense of what's valuable and important, what means something, where actual value lies is getting lost in this noise cloud of just garbage that we're surrounded by. It's very frustrating to me. And we need to be looking at that sort of basic underpinning of who we are and how we are and what we do about things. I'm surprised that nobody in this room has said, okay, you guys, I believe you. I get it. Now what can I do? Come on, somebody raise your hand, say, what can I do? All right, fine. Okay, I didn't even plant you here.
I would like to point out that I'm pretty sure that none of you came here thinking you would hear the words narcissistic pleasuring put together in such an eloquent answer. I thought that was beautiful. Right? So take away that term. That's a T-shirt. Go for that.
Let me just say,
take that one step further.
That was beautiful.
Actually,
No, I'm not going there, but that was beautiful. That was beautiful.
let me just continue the discussion just to let everybody know we have gone about 14 minutes over. But the discussion is so engaging. We're going to continue it. Just to let everybody in the room know as well, in the Hampton Roads, Virginia area, we have about 60 to 70 people that are gathered at Old Dominion University that are watching this live as well. And they have been submitting some questions. We're going to continue with the questioning for probably about 5 to 10 more minutes because it is late on the East Coast and we want to make sure that they get home safely. So we'll continue with this beautiful woman in the back.
That is so nice. I don't think this is on. Is it on? Okay.
Grab it again.
Jim and James, wonderful presentation. I think my question was actually just stolen across the room. But I was looking for a comment on Senator Ted Cruz's new wonderful role. And maybe just that is just an answer enough. Jim, thank you.
Hi, Austin. How are you doing?
Hi, how are you? No, just a comment in terms of leadership, in terms of, how are we supposed to form policy when we're putting people in roles that are blatantly very obvious against a scientific fact, which is embarrassing. Sorry.
Don't know if we even need to answer that.
You already answered it over there.
Yeah, no, it is an interesting world we live in where people who have come right out and said, I don't believe climate change is happening, are in charge of the agencies that monitor the planet, like NASA and NOAA. This is, as a scientist, it makes me very nervous.
Okay, let's...
Question, you said, what do we do? What do we do? It seems like such a huge issue. Like, what do I do?
It ties into the political issue in detail on an individual level. It feels so damn frustrating that there's 300 some million of us and there's those 100 people in the Senate and however many 450 representatives there, and it feels so hard to get your opinion and your concerns represented by those guys. But I think the number one thing we can all do, because I don't know who's got skill as a financial engineer or a creator of wind turbines or who knows how to caulk windows and reduce heat wastage here in this building or whatever it is. I can't speak to that stuff. Only you can look into your hearts and see what you can do in your individual worlds. But what I do know is that everybody in this room and all 315 million people in this country have a voice. You have brains, you react to the world around you, you assimilate that sensory experience, you assimilate the knowledge experience, and you can put that out in terms of how you speak the truth to the world. And these guys who are beholden to financial interests that are manipulating the political system have to be called out over and over and over again. This isn't right any more than some of the previous manipulations of public health policy were manipulated in service to the tobacco companies.
Thank you. We have an online question. Sarah?
Yes, I'm going to adapt this a little bit because I have, with Dave, been down in this area, and I'm going to try to get you guys to focus on the Norfolk region since we have a large audience watching from there right now. And the question is, considering that we have committed to a large magnitude of climate change and a large sea level rise issue, and taking responsibility for our children and their children, it is time to start cleaning up the coastal zone and preparing for massive inundation. So My question to that area in particular, what would you tell the business owners, the politicians, the people trying to make decisions down in the Norfolk region about what they should do right now to prepare?
Well, I'll start with that. I think they need to do two things. I think number one, you need to be prepared. The sea level is rising. It will continue to rise. Adapt. There's a certain level of adaptation you just simply have to do. And I think the more you know about the future in terms of sea level rise, the better you can adapt. The second thing that I want everyone in Norfolk to do is get mad. All right? Yell, scream. The way I put it is simply this. If the troops on the front line don't complain about how the war is going, the generals back in Washington won't care. All right? And you folks here in Breckenridge and you folks in Norfolk, you are the troops on the front line. You care about snow. They care about sea level. These are big issues to you folks, and you should be yelling and screaming about those things. And it's about time we raised the level of concern. We raised the level of just the volume of voices out there.
Yeah, I think that's a great analogy. I liken it to, you know, we in this climate community 6, 7 years ago, we were still very focused on sort of reasonable dialogue. Let's have a give and take. And on the media, it's always two opposing viewpoints. And it happens to be that 99% of the information is on the side of one of the speakers and about 1% of the information is on the other side. But they were supposed to have equal voice and equal weight. They were supposed to be equally intelligent when they weren't. And the, so sorry, I rambled there a little bit. But I think about the time for sort of this calm, hey, let's exchange views phase of this conversation is over. When a lion is charging you, you don't stand there and have a reasoned debate with that lion and say, lion, come on, let's talk about this. I know you're hungry, I know you're mad at me, but just stop and talk about it. We've got an immediate threat to life, limb, and civilization confronting us right now. And it's time to start getting angry. Time to start raising our voices. I've got 2 kids. I've got a 13-year-old and a 26-year-old. And this project is, in essence, my offering to them, to those girls, to say, look, I'm doing what I know how to do in my time and space and knowledge. And we all have that because the situation is urgent. This is not something that's going to happen 50 years from now. It's happening right now.
Question? Aaron?
Hi. Aaron, I just wanted to follow on Tom's question about the frustration of, you know, scientists having these facts about climate changing and the public not necessarily believing. And you guys talked this morning a bit about belief, and I wondered if you could say a little more to this audience about the language of belief versus physical laws.
Many times I get asked, so you're one of those guys who believes in climate change. That's always the word I hear. You believe in climate change. And that's always by somebody who doesn't believe in climate change. And my answer is always, no, I don't believe in climate change any more than you do. I actually think that climate change is happening based on the evidence that I understand. And that smart guys like Jim White and tens of thousands of other smart men and women around the world who've studied this stuff understand. This is about facts. Belief is about ideology and doctrine, whether it's inherited or it's adopted or it's religious or whatever. This is not a question of doctrine and ideology. This is a universal problem that applies universally to all of us. And if we can get the conversation out of the level of belief, then we get it out of this polarized political camp situation that it has been. This applies, all the Republicans and all the Democrats are going to be damaged by climate change. It's not political. This is ecumenical. It applies across the board. And we have to get this out of the realm of belief and doctrine and get it into the realm of reasoned thought and understanding. And that's what we're constantly rolling the Sisyphean stone uphill trying to accomplish.
So the ice has already melted and the temperature's always risen, but if we were to stop it, would the ice be able to come back? And do we need that ice to come back if we were to stop?
That's a great question. The ice could come back eventually, and it depends on the size of ice mass that we're talking about as to whether it will come back quickly or come back slowly, but yes, the ice would eventually come back. I want to emphasize, though, that this is not fundamentally a story where I'm stressed out about endangered glaciers. You know, there will be glaciers around in a lot of places for a long time. I happen to think that the Alps of France and Switzerland are a lot prettier with glaciers coming down than without them, but they'll still be beautiful without the glaciers. What's more important is that we recognize that the glaciers are sort of the canary in the global coal mine. It's a three-dimensional manifestation of climate change, and it gives us a way to think about climate change because we can see it with our eyes. It's not abstract and imaginary. But yes, the ice will come back sooner or later as we turn the tide of history in a different direction.
This is great. Thank you very much. I think we have one more question here in the audience, and then we're going to wrap it up. But please, go ahead.
Just a quick question about, Jim mentioned that there was a point in history hundreds of thousands of years ago where there was no ice on the planet. And so that can happen naturally, but then looking at the graph that James had shown where the carbon levels are so high, even during that time when there was no ice on the planet, the carbon levels or the greenhouse gases, they were never as high as they are today?
It's a great question. No, if you go back 40 million years, CO2 levels were probably in the 1,000 to 1,500 parts per million range, so they were significantly high. The last time the Earth saw 400 parts per million CO2 was about 3 million years ago, a long time ago. So we're out of bounds. But the climate 3 million years ago was much warmer than it is today. 3 million years ago, sea level was about 60 feet higher than today. Basically, we lost a full state. Delaware's gone, right? So that's what 400 parts per million CO2 means. If we go to 600, 700, 1,000 parts per million, then you'll see an even bigger change. You'll see and again, it's still our planet. It's just going to have less ice on it and a lot more sea, a lot more ocean.
I'd like to drop one more thought into the mix here. It has nothing to do with physical science. It has everything to do with psychology. All of us can get depressed about this issue when you live around it as regularly as we do. And the frustration that social action never seems to be quite enough. And in the end, we have essentially a binary choice. You have a choice to be optimistic and to plan for action, plan to do something positive, hope, frankly, that we will rise to the challenges in front of us. Or you have a plan to say, hey, that's too painful of a thing for me to contemplate. I'm going into my cynicism about the human race, and I'm going to be negative, and I'm going to hide from this and say, hey, we're a lost cause. And some people do exactly that. But in my own particular life and in the lives and mentality of so many of us in this field, you make a binary choice to be optimistic. Without optimism, nobody ever gets anywhere. Nobody ever flew rocket ships to the moon. Nobody ever walked across Australia. Nobody ever did anything without optimism and without expecting to confront adversity. Big things don't happen without confronting adversity. Adversity is part of the process of accomplishing big things. So we have adversity. I don't see why we should be cynical and pessimistic about that. We should be optimistic and go forward.
James, I'm wondering if you can just take a moment and let everybody in the room here know, and let those watching online, how they can get a hold of Chasing Ice. Where can they access it? How can they watch it?
Thank you. Chasing Ice is available on Netflix, on iTunes, by DVD from the various mail order houses, and National Geographic Channel. It comes up in rotation every so often.
That's terrific. Ladies and gentlemen, you have been a wonderful audience that has participated. Your eyes have been on the screen and on these two gentlemen all night, and we really appreciate that. It shows your interest. Thank you to the town of Breckenridge for making you all aware of this event. We will continue tomorrow morning with the TV weathercasters and meteorologists talking about the importance of water and water security in drought-stricken areas and around the world as well. For those of you watching online, thank you so much for joining us tonight. This is the first time we've really connected Colorado with another coastline in the Norfolk, Hampton Roads area. Thank you so much for coming in and participating and asking those questions. I wish you all a safe drive home on the East Coast and wherever you are watching around the country and around the world. And thank you here in Breckenridge for coming in to enjoy this hour-and-a-half time. So thank you so much.